All right, let's get started, folks. I don't think I need a mic for this small track. What we're going to be discussing is, this is a complement to what I have done a few hours ago on multi-master replication. This is more into DDL replication, some of the use cases, and some of the challenges that Lahari, who is our software test engineer, right, at pgEdge. Larry, you want to take up?
Hi, everyone. Good afternoon.
Next. I'll be the slide guy.
Okay. So my name is Lahari. I'm working as a software test engineer in pgEdge from past 1.5 years. I do testing in pgEdge on various features by writing code in Python and Perl languages and sometimes integrating them too. So my co-speaker here is Hari. We all know about Hari, so I think we don't need any special introduction about him. So today we are going to talk about automatic DDL replication with, let me show the title. Yeah, automatic DDL replication with pgEdge distributed Postgres. So now, so here you can see our agenda here is to first talk about what is DDL replication and its use cases. So, here you can see that where and for what problem this DDL replication is used and how it is useful in the real-time environment. So, in a dynamic environment, schema changes are inevitable. So, the schema changes that we make or need to be propagated across all the nodes. One second. Sorry. So to propagate these schema changes across the multiple nodes is a major challenge. So here the DDL replication, it will cause some failure, and failure of this DDL replication will lead to inconsistency and downtime. And then we'll talk about the importance of DDL replication on production systems where the end users or customers can actively use it. For example, if we consider that if there is a holiday sale and at the peak time, if you want to do a small change in schema and if it if it fails, it could bring down the key services down, and DDL replication safeguards that to keep the system in sync. So, and then we'll have a demo about the DDL replication on pgEdge platform. Now we'll have an understanding about DDL replication in MMR, and also talk about multi-master replication. So as a Postgres developer, you all know the importance of having scalable, robust, and high availability database solutions to propagate, to handle the large amount of read or write data. So this is where the distributed Postgres or multi-master comes into the picture. So Hari had given a session, clear session about the multi-master replication this morning. So I don't want to get into that. I'll just have a small definition of multi-master replication, and you all know about that. So multi-master distributed Postgres allows us to have a multiple master databases across different locations, like different nodes, where we can do read or write operations simultaneously. And also for the better performance of applications, we use the bidirectional replication and a conflict resolution. So here on top of multi-master, we are going to use the DDL operations. So let me give a short explanation of DDL here. So DDL is used to define the database structure, especially the database schema. So, alter, create, drops are some of the examples of the SQL statements in DDL, but they also include, some information operations with databases, tables, columns, indexes, and views. And let us see why is it important. I need to specify some few points about the importance of it. Number one is unified schema. So regardless of where a schema change is made, it is necessary to propagate these schema changes across all the nodes. So, and then we'll have automatic synchronization. So if the system has an automatic synchronization, the database administrator need not to be manually intervene and do some operations on it. And then we'll have a scalability. As the system grows more and more, and if we add more nodes to it, so DDL replication ensures that the new nodes created will have the new schema changes received by these new nodes too. And then so we'll see about some limitations and the current scenario and the challenges that we have faced. So when Postgres is configured in multi-master or distributed database, and multi-master setup or distributed, it typically relies on replication for synchronizing the data across all the nodes. But Postgres native logical replication lacks the capability of having the DDL changes. So Postgres supports this multi-master replication through third-party extensions like bidirectional replication and PG logical. Even though it has some limitations. What are those limitations? Number one, it's limited DDL support. Some DDL operations may not be supported by all the third-party extensions or tools. For instance, operations which involves the complex schema changes, like such as altering column types or renaming a table. And then we'll talk about race conditions and conflicts. This is one of the challenge. In a multi-master environment, if DDL changes are made simultaneously across all the nodes, obviously we will see conflicts in it. Right? So this might require a manual resolution. This is one of the challenge. And then we also have the dependency issues. So DDL often have dependency issues like, a foreign key or triggers, ensuring that maintaining these dependencies are maintained properly across all the nodes is really quite challenging, especially if DDL changes are not replicated in the correct order. And then performance impact. So replicating the DDL changes, if we done it manually, it is obviously a time consuming, which causes the downtime, and a database administrator or a developer need to manually intervene to modify these changes. This obviously impacts on the performance.
So, it is very prudent for us to say that there are some safe harbor statements that needs to be there, right? All the limitations that are part and parcel of Postgres logical replication, right, are not solved by pgEdge or are not solved by pgEdge platform, in a whole way, right? It's still, developing. The DDL replication is a very, very complex, right? When we are digging into some of the issues, there are so many corner cases, right? And all the corner cases are not yet resolved in pgEdge platform, right? But at the outset, when you look at some of the bare minimum or some of the less complex things like altering a table, with default values, or most of the schema changes that the application developers would like to have are covered. Some of the corner cases is when we are working with triggers, right? Event triggers, right? It's that itself is a pretty big mover to get into and then resolve a lot of those corner cases, right? So in a nutshell, what we are trying to say is whatever the limitations that we have on the core community Postgres are not yet completely resolved, right? But we're getting there. Good.
So now we'll talk about the pgEdge platform DDL replication capability. So pgEdge also uses Postgres logical replication under hood, but here we came up with Spock extension. So it is designed in such a way that it can handle the replication of DDL statements, not only the DML and transactional data. So let me give you a little bit info about the Spock extension. So we use PG logical here, bringing to the current version of Postgres and making an asynchronous multi-master replication feature and conflict resolution mechanism, which are the basics of Spock extension. So I think in the morning session, Hari gave a little bit info of Spock extension. And then we'll see clearly in the demo, like how we are using this extension and how we are making these DDL operations. And one more thing here is, the unique feature of Spock is, when user can read and write transactions on any master node simultaneously, this extension captures all the conflict resolutions and stores them in a Postgres table. So the user can see that where there is a conflict arise, by going through that table. And then we'll have the benefits of replication with pgEdge.
So when we say under the hood, it is all pure logical replication, whatever that was part and parcel of PG logical, whatever that was part and parcel of BDR1, right? The BDR1, which is the open source bidirectional replication extension we had a decade ago, right? All of those were picked up, right? That has become Spock. And on top of Spock, some of the super cool engineers that we have had with pgEdge, right? That have written products like Slowney, that have contributed to products like PG Logical, right, have designed that Spock extension. And Spock extension, when we look at multi-master, it's cool, right? You set up multi-master nodes, your application is writing to any master that it has got the connection concentration layer sorted out, right? But when it comes to the automatic DDL replication, right, the whole of schema changes, right, that is purely taken care by another worker of Spock, right? The Spock worker, which is exclusively for the DDL replication, right? That's another important thing. One way to look at it is, right, if you stream the data, right, the transactions that are happening from the application versus the DDLs that are going to happen, right? DDLs in most cases will be a controlled operation, right? But that's just a statement that we can say, right? You could look at schema changes at any point of time, right? Your application developer comes up and says, hey, I would like to have this column added for a flag that I need, or anything for that matter, right? So these changes will go through via a Spock supervisor process that keeps a track of, okay, the data is segregated, the DDLs are separate, right? This is taken care by the replication sets that are exclusively created for DDLs again, right? That's where your consistency guarantee comes up in most of the cases. Again, right? It is a safe harbor statement that I would want to make. Most of the cases, it is consistency guaranteed, meaning all the changes that are happening on node 1 will also go to your node 2 and node 3 if you are talking about a 3-node cluster. The ease of use is more of, Lahari is doing a great job of covering it. But if I were to look at a multi-master system, right, and then, or for that matter, not even a multi-master system, but look at a Postgres logical replication system, and I would like to do schema changes, I know the pain, right? I got to make sure the subscriptions are disabled, right? My whole logical, replication is halted for a while, do the DDL change, and then again, enable the subscription, right? So there is a ton of manual intervention that needs to be there, right? That is the exact exertion of pressure that we would like to take off of our database engineers, right?
To tell the benefits of DDL replication with pgEdge, let me give you a real-time example. So consider a global e-commerce company which has a massive Postgres database and which is serving a millions of customers across the world. So now, how you can see operational efficiency over there. So with pgEdge DDL replication, the company can apply these schema changes on its primary database, and it can be seamlessly replicated to all the replicas without any downtime. So this means there is no interruption in the service and during the high traffic periods. And developers and DBAs can push their updates frequently and maintaining a level of operational efficiency over there. And then, so how it satisfies the high availability? So pgEdge DDL replication allows the company to maintain the multiple masters across the across the different geographical locations. Suppose if a primary database if a primary database experiences a failure, the traffic can be redirected to the replica with latest DDL updates. So this approach supports a failover strategy, reducing the risk of significant outages. And then coming to scalability, the company can scale horizontally by increasing the more number of master nodes at any point of time without any discrepancies. So this is one of the real-time example which can satisfy all the three statements I have given here. And then, so these are some of the Spark GUCs or GUCs that we are going to use to have the automatic DDL replication on pgEdge platform. So we all know that GUC stands for Grand Unified Configuration in Postgres. So it manages the configuration parameters in the PostgreSQL configuration file. So by understanding these parameters, the database administrators can optimize their Postgres to meet their specific specific workloads. So we'll come to know the detailed information of these GUCs while doing the demo.
While doing the demo, right, you can go up to the demo, but how many of you are happy that to see the last statement, pg reload conf, right? Not restarting the database, but reload configuration, right? That gives me peace of mind, right? I'm not going to go ahead and do a change management to restart the databases and so on and so forth, right? Please. You want to go ahead with the demo?
So let me show the demo here. So for time being, I'm quickly walking through the demo. So so the first step here is to set up an pgEdge platform. So our current version, CLI version here is 24.7.7, which is the latest version. And then you need to set up an pgEdge platform here, and we can see the version of pgEdge and what version of Python 3 we are supporting. And then, yeah.
So most of you all have done the pgEdge installation, I believe so, right? If not, there's a super cool and super easy documentation available on docs.pgedge.com. You should be able to follow that with very less supervision, I'd say.
So here I took two consoles here, considering the right one as node 2 and left side as node 1. And then so we can see that pgEdge is installed, and then we are going with going into the pgEdge directory and setting up the pgEdge by giving the username, database, and password, and specifying the port number here. And also you can see the version we are using here is 16, and the Spark version is 401, which is the latest version. And you can see here it is installing PG16, and also we are doing it parallelly on both N1 and N2. And here if you see that create extension if not exists Spark Cascade, which means the Spark extension has been created here along with Snowflake extension. And then what we are doing here is we are going to create node 1 here by giving the command /pgEdge spark node create n1 and giving the host and specifying the port number, your OS user, and database name. So you can see here where we got the node ID here stating that 49708 is on the left side, and you can see 26863 on the right side. Two different nodes created here, and then we can see reloading of configuration file. And at later point of time, we are going to create the subscription, cross-wiring between the nodes N1 and N2 to have communication. So here you can see Spark sub create sub underscore N1 N2, which means we have subscription from N1 to N2. And the port number we specify here is port number of N2. And then as usual, the user, OS user, database name in the string, and end up with the database. And you can see the subscription created here on both the nodes. So you can see on the right side, we got the sub create, which is sub underscore N2 to N1 and giving the port number of N1. This we should be very careful while creating the subscriptions. Otherwise, we'll get into some errors. And we can see on left-hand side, we got two nodes here because since subscription is created successfully on both the nodes, we can see N1 and N2 on left side, and as well as we can see the same on N2 as well, on node 2 as well. And then we can see, by giving the command spark.subShow status, which means it shows the status of the subscription that is created by stating the status of that, whether it is replicating, and also the provider node. On left side, we can see the provider node here is N2, and then the host name and port number and user as usual. And we can see same on the node 2 as well. Now what we do is we give some of the commands like to enable DDL replication. The first one is spark.enable DDL replication, which enables the replication. But you can see here the status now here is off on both the nodes. And also Spark include DDL repset, which again shows the off. And the third one is spark.allow DDL from functions, which is again off. So, and then what we'll do is we'll give alter system spark.enable DDL replication is equal to on, which is one of the GUCs that I have showed in the previous slide. And then all the three GUCs that I mentioned in this slide are given on both node 1 and node 2. And we can see that we are giving select PG reload configuration, which is, and after that, if we check the status, you can clearly see that now it came into the state of on. So now what we are doing is we are going to create table on N1 by giving the primary key. So here you can see that DDL statement is replicated, which means that the same table is created on N2 as well. And we can see by giving that select star from spark.tables, where we got table T1. And we can see that same on N1 as well. And now what I'm doing is I am trying to create a table T2 without primary key. And you can see that the same is replicated on N1 as well. So if you see here, select star from spock.tables again, you can see the table names T1 and T2. And here you can see that these tables are added to two different replication sets. The table which is created with primary key is added to default replication set, and the table which is created without primary key is added to default insert only replication set. So now,
Just a pause here.
yeah.
So when we're looking at the base or the elementary condition for us to enable logical replication is that we should have primary keys on both the all the tables, right? If there is no primary key, we'll rely on the replica identity, right? And replica identity is an extremely costly affair, because you are going to be constructing hashes, you're going to be constructing CTIDs and the whole system related functions on the entire row, right? So you do not want to have that costly affair when we are doing that logical replication. Because we're going to be doing a mesh, right? N1 to N2 and then N2 to N1, right? You do not want to have that replica identity. What we did is we segregated the whole non-primary key tables, right? Created a different replication set for that, right? That replication set is the default insert only, right? What would happen if there is a table without primary key, you went ahead and added to the, you created the DDL, right? And you create an update on that, right? Now from Spock 4.0 onwards, which is the latest and greatest that is available on Spock extension, it does not fail the replication, it does not break the replication. But in our previous versions, we have had instances where it broke the entire replication, right? N1 was communicating to N2, N2 was not able to communicate back, right? So those acknowledgements were missing some reason, right? With 4.0, it does not break the replication anymore, right? But then the update does not get transported to the N2 with, that goes without saying, right? So this default insert only has been a real cool way of making sure, even if the application developer or the user, without the knowledge of having primary keys and the association of primary keys and the logical replication, even if they do the DDLs, we are able to replicate them, right, using this replication set.
So then we can see I have inserted some values in table T1, and these are replicated on both nodes as well. And then I am going to alter the table T2 by adding a primary key to it on node N1. And then if you see that when I do select star again from spock.tables, we can see that table T2 is added to the default replication set. So this is a brief demo about the DDL replication on pgEdge platform.
You showed the, can you go to the demo and show the last, yeah, last the track Go to the last 1 minute. Can you show what replication sets these two are on? No, right?
Yeah.
So what we wanted to show was once the primary key gets created on the second table, right? So the replication set automatically changes from default insert only to the default replication set.
So these are the statements I have mentioned here, which I showed in the demo. So yeah, this is a conclusion here. So if you want a demo, you can reach us. So we can discuss in offline in clearly about that. Yeah, thank you so much.
Okay. Hey, hi. In the demo you showed, you created one extension called Snowflake, right? What does that mean? Like, what purpose we need that extension?
So from a multi-master replication standpoint, right? So because the native sequences cannot help us anymore, right? So there are multiple writers, there are multiple application silos that are happening. So what we were wanting to do is we wanted to make sure node-specific sequences to be created. We looked at multiple options, and Snowflake sequences seems to be a good option for us to pick up, right? This is again a completely open source project, right? So we do not have any. Basically, it's a Postgres licensed project. Our aim is to make sure that going forward, right, when the sequences get a lot more complex, Snowflake would be one of our allies. The Snowflake works on a node ID, right? So obviously your node ID is always unique, right? And then it also picks up your timestamp, right? And it also picks up some random number. All of these will become a 64-bit number and digit that gets auto-generated, right? It's not a caveat per se, but when we say Snowflake IDs, right? They are relatively long, big integers, right? So you cannot do any arithmetic calculations on those ID, right? If you are calculating, doing any arithmetic calculations on those IDs, there's something wrong with the model per se, right? We have one final question. Yeah, Pawan.
Yeah. In the default insert queue, whenever the table is in the default insert queue, it means that the updates or deletes are not happening on the table. Is that it?
The assumption is yes. So we are looking at an append-only table, right? So you don't care, whether the data gets mangled, whether the data gets, modeled, or not. As a matter of fact, it's only an insert-only and append-only table.
Yeah, it means the updates or deletes means are restricted.
Don't happen. That's the expectation, right?
Yeah.
Yeah. Funny things happen on production.
Yeah. Yeah. And I have one more doubt. Like, consider this scenario, like we have 3 nodes in the pgEdge, and in one of the node, I am creating a DDL statement. The second node was rebooting during that point of time, and it got propagated to third node. And when the second node comes up, will this DDL get synced?
Everything is part of walls.
Okay. So
it's a simple replication slot that is going to broadcast the changes.
Yeah. Same underlying things will be propagated. Yeah.
Thank you so much, folks. We'll get ready to the next session probably. Right? Good job.